Let's find the volume of the solid of revolution obtained by rotating the region bounded by the parabola y equals x squared, the line y equals x, as this region is rotated about the vertical line x equal to 4. So the region looks like this. Here is the parabola part, this is the part of the line, and the point of intersection up here is 1, 1, so the x coordinate is 1, y coordinate is also 1. Let's bring in the axis of rotation. This is a line x equal to 4, and all we need to do is to sketch where this region will end up 180 degrees into the rotation on the other side. So this is what it looks like. Now we're going to be integrating with respect to y, so we need to solve for y, not for y in terms of x, but instead for x in terms of y. Now this line, y equals x, already solved, x equals to y. The parabola, if we take square root of both sides, gives us x equal to plus or minus the square root of y. Now the minus part is in the second quadrant, but our region is in the first, so x is equal to positive square root of y. Let me label these. This is x equal to y, and the parabola is expressed x equal to the square root of y. Now pick a typical y, any y between 0 and 1. Keep track of this horizontal piece of the area. As it rotates around this line, this part is hollow. There's nothing there. There's no volume. However, this part has volume. So what we need to do is find the area of this washer as a function of y, and we're going to be able to solve this problem. So notice that the center of this washer is on the axis of rotation, which is x equal to 4. Always, always, when finding the radius of the big circle and the small circle, refer back to the original region, not to its 180 degree reflection on the other side. Recall that when we have a washer, the inner circle, let's call its radius little r, and the big circle has radius big R. The area between the two circles is pi times big R squared minus pi times little r squared, or pi times capital R squared minus the little r squared. We need to express the big radius and the small radius of this washer that we just generated as a function of y. Now always go back to the original region. The big radius is right over here, this distance. Let's call that capital R. And the small radius, let's say, is this distance up to here. Let's call it little r. Now notice that the big radius, the distance between the y-axis and the line x equal to 4 is 4 units. That's too big. We're going to subtract this part right over here. That part happens to be the x-coordinate on the line. When the y-coordinate is y, the x-coordinate is also y, so it's 4 minus y. And for the small radius, we're going to subtract this part from 4, because again the distance from the y-axis to the line is 4 units. We're going to subtract this much. This happens to be the x-coordinate on the parabola, which is square root of y. So little radius is 4 minus the square root of y. And now we have everything we need to find a volume, and the volume will be pi times the integral from 0 to 1 big radius, that's 4 minus y squared, minus small radius, 4 minus the square root of y squared. Of course, integrated with respect to y. So let's simplify this. This is pi times the integral between 0 and 1. We have 16 minus 8y plus y squared minus 16 minus 8 times the square root of y plus y. And we're going to, of course, integrate this with respect to y. 16s cancel, and we have minus 8y minus a y right over here. That's minus 9y plus y squared, that doesn't cancel with anything, and then minus a minus 8 square root of y, that's plus 8 times the square root of y. And let's go ahead and integrate this. We have pi times the integral of minus 9y is minus 9 over 2y squared plus 1 over 3y cubed, and then the integral of square root of y, so this will be plus 8 times 2/3 y to the 3/2 evaluated between 0 and 1. So plugging in 0 will give us 0, of course. Let's plug in 1. We have pi minus 9/2 plus 1/3, and then 8 times 2/3 would be plus 16 over 3. The common denominator is 6, so we have pi times minus 27 plus 2 plus 32 all over 6. 32 plus 2 is 34, minus 27 is 7, so the final answer is 7 pi over 6 units cubed. And that's the volume of the solid of revolution 4. More videos